He has published more than 26 national and international publications. He has MA, MBA, MPhil, and PhD degrees as academic qualification. He has already guided one student for the PhD. He is currently guiding three students for their PhD under Mangalore University. Recently, he has been awarded as a national award by AIACHE as Best Innovative Faculty 2021. So thank you. Over to you, sir.
Okay, thank you, sir, for your introduction. Now, let me start with the topic solutions. I am using the whiteboard method for the presentation, and let me go ahead with that. Okay. Students, please see, I will be covering this topic on solutions. I would like to ask you, what is a solution? Solution, when we say in chemistry, it is a homogeneous mixture. Homogeneous mixture. Solute. Let me give some explanation here. When a little sugar is put in water and stirred, it is called sugar solution. A little salt is taken and to a glass of water, you add and stir, salt will completely dissolve and make a salt solution. Therefore, solution means homogeneous mixture. Homogeneous mixture is one which is transparent. It looks like water, but it has a solute in it. That is called. The particle size is less than 10 to the power minus 9 meter. Means it should be less than 1 nanometer. Then it is solution. If it is more than 10 to the power minus 9 meter, that is 1 nanometer, 1 to 100 nanometer, then it is called colloid. Colloid is not homogeneous, it is heterogeneous. This is homogeneous. And the third one is called suspension. When particles are still bigger in size, we call it as a precipitate. Therefore, we can divide three systems now: solution, colloid, and suspension. I am taking only solutions today in this class. Now, we will be going for what is saturated solution. What is saturated solution? I am giving an example. Let us take sugar, put it into water. Let us say 50 ml of water you take and add 1 teaspoon of sugar, stir, it dissolves. Add little more, 1 more teaspoon, dissolves. You go on doing it, you will get to a stage where if you add sugar, it doesn't dissolve, it remains at the bottom. Then I call it a saturated solution. Therefore, what is saturated solution? Saturated solution is one in which WHICH, no further dissolution. Solute cannot be dissolved. No further dissolution of solute possible. At a given temperature. Why I say at a given temperature? If I put more temperature, that also, which was insoluble, also will dissolve. Therefore, saturation is at a given temperature, is it saturated or not? Okay, this is an idea. Next, once you know that, we will go for types of solution. You can have 9 types of solution. Which are the 9 types we can take? You have solute and solvent. I will write here. One side solute, another one solvent. Now we know that matter exists in 3 states. Here I can have solid, here I can have solid. Here I can have solid, here I can have liquid. Here I can have solid, here I can have gas. Three are already here. Similarly, I can go on liquid, I will put solid, liquid, 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 gas. Last one will go for gas, solid, gas, you can go for liquid, gas, you can have a gas. Let me take an example of a gas in a gas. I will take few important examples. Solid in a liquid, as I said, sugar solution, salt solution come under this category. Liquid in a liquid, I can give you alcohol and water. Alcohol and water is an example where liquid in a liquid. Gas in a gas is air. We know that air contains gases. Which are the gases which are generally present in air? Air contains nitrogen 78%, oxygen 21%, and so many noble gases are also there. And what is that? Water vapor is there, other things are there. Therefore, it is a gas in a gas. Therefore, don't be under the impression that two components only need to be there. You can have more than two components, but it should be homogeneous, completely mixed with one another. You can have 4, 5 components also can be there. It can be called a solution. Generally, we are speaking about solute in a solvent. One which is less is called solute. One is present to a larger extent is called solvent. We will move further. Otherwise, we will go here. Having some problem. We will move down. Oops. Hold on. Yes. We'll go with a fresh board. New page. Yes. Now, let me give you how to express concentration of solution. In your first PUC, you have studied how do you express the concentration of a solution. We heard about ppm. Do you know what is ppm? Parts per million. Parts per million. Or I can say number of milligrams present in 1 liter. This is the meaning, parts per million. Okay. Or you can have molarity. Hope you know what is molarity. Number of moles present in a liter. That is called molarity. There is one called molality. What is molality? Number of moles present in 1 kg of liter of solution. Yeah, liter of solution. Here 1 kg of solvent. See the difference. Here it is meant for solvent. Here it is solution. I will explain with example. Okay. Then there is normality. Then there is mole fraction. This also I will explain with example. What is mole fraction? Number of moles of one component to total number of moles. Total number of moles of all components. This is called mole fraction. Components, yes, also we can write. Okay, now I will explain this with 1-2 examples. Quickly we'll do. Let us say example. And there is one more called percentage solution. We'll start here. Okay, I will start with ppm. If 5 milligrams of glucose is in 1 liter of solution, that is equal to 5 milligrams, I can write it as 5 into 10 to the power minus 3 grams. Do you agree? Divided by 1 liter is 1000, 10 to the power 3 centimeter cube, cm cube. Therefore, is it not equal to 5 into 10 to the power minus 6 gram per cc? That is equal to, this is million. Therefore, multiply by 10 to the power 6. Million is 10 to the power 6. This will cancel. Therefore, answer will become 5 ppm. Therefore, I already told you number of milligrams per liter. Therefore, my 5 milligrams in 1 liter is 5 ppm. 10 milligrams in a liter will become 10 ppm, like that. That is. We'll go to the second one, molarity. I will take, let us say, 9 grams of glucose in 1 liter. 9 grams is how many moles? Number of moles. Number of moles of glucose. Can you tell me? How do you find number of moles? Mass divided by molar mass. This is the formula. Mass is how much? 9 grams. What is the molar mass of glucose? Please remember, glucose is written as C6H12O6. You can find carbon is 12, 12 into 6, 72, 1 into 2, 12, 12, 6 into 16, 96, all that comes to 180. Therefore, this is called moles. Therefore, how much it comes? 1 by 20. 1 by 20 is 0.05. This is the moles. Now, these many moles are present in what? 1 liter. Is it not molarity? Therefore, molarity is equal to 0.05. How do you find molarity? First, find out number of moles per liter. How do you find moles? Mass by molar mass. Mass by molar mass will give you number of moles, and that in liter will give you molarity. This is the second. We'll go to the next slide. Choose the next slide. Yes, we'll go for the third slide. Done. Yes, it will take little time. Okay. Molarity is over. I will go for molality and explain that. Molarity now. Molality is given as small m. What is molality? It is number of moles in 1 kg of solvent. Number of moles in 1 kg of solvent. Not solution, solvent. See the difference. Therefore, if I say, I will take a different example. Yeah? 5 grams of glucose in 200 grams of water. Let us see. What is the molality I want? 5 grams in 200 grams of water. Therefore, how many grams in 1 kg, that is 1000 grams of water. Can you find out? It is simple. You can say solute. Here I will write. Here I will write solvent. Solute is 5. Here I will give 5 grams. Solvent is here I will write. Here it is 200. Therefore, how much is the solute we will take? How much is the solvent for 1000 grams? You can cross multiply and you would get here 5 into 1000 divided by 200. This will come to 25 grams. Therefore, you can say 25 grams of glucose in 1000 grams of water. Now, how many moles it will be? Therefore, number of moles, I will write. Number of moles of glucose, if I take 25 grams divided by molar mass of glucose is 180. 180. Therefore, this formula you have to find out and do it. We can do it still. I will help you to do that. 5 is the 25. 5, 3 is the 15. 30, 5, 6 the 30. Therefore, you would get something like 36 by 5 by 36. This is the molality. It should be given as m, small m, molality. I am not working out. It's a fraction. It comes 5 by 36. You can take a calculator and find. This is called molality. There is a difference between molarity and molality. Please remember. Fourth one. Percentage solution. Percentage solution is simple. If 5 grams of glucose is dissolved in 95 grams of water. Now, what is the percentage would be? Percentage solution is equal to, you are not doing moles, you are just writing 5, number of solute. Now, denominator should be solvent plus solute. Numerator should be the solute, denominator should be solvent plus solute. That will be equal to 5 by 100. That will be equal to 0.05. This is called this into 100. Percentage when you do, you have to multiply by 100. Multiply here. Multiply by 100. That will become equal to 5%. This is equal to 5% solution. That is called percentage solution. That is the fourth one. Yes. Yes. We are going for next one. What is the next one? After finding out molarity, we will be going to mole fraction. I will give an example. Mole fraction is, if 7 grams of nitrogen and 8 grams of oxygen are present, find its mole fraction. We'll do it. What do you have to do? Number of moles of nitrogen. Number of moles of nitrogen. How to find number of moles of nitrogen? Mass divided by molar mass of nitrogen. One nitrogen is 14. Two nitrogens are 28. Therefore, 7 by 28 is 1 by 4. 1 by 4 is 0.25. Similarly, number of moles of oxygen is also 8 by molar mass of oxygen. 1 oxygen is 16. 2 oxygen is 16 into 2, 32. Therefore, 32 if you write. 8 by 32 is again 0.25. Therefore, if I write what is the mole fraction of nitrogen, it is to be done number of moles of nitrogen divided by total number of moles. Total number of moles is how much? 0.25 by 0.25. Together is 0.5. 0.25 plus 0.25. 0.5. Is it not equal to 1 by 2? 0.5. This is called mole fraction of nitrogen. Similarly, mole fraction of oxygen would be again same. How much? 0.25 by 0.5. 0.5 only. Or I can do 1 minus 0.5. Sum of the mole fraction should be equal to 1. 1 minus 0.5 is also equal to 0.5. Therefore, this is another method of expressing the concentration. Therefore, I have told you the different methods of expressing concentration except for normality. Right now, we will not look into that because we have to cover other portion in the solution chapter. This is a very small thing about the concentration that we have touched upon. Now we will be going for the other continuation of the subject in that. Yes. We will be going for solubility of solids in liquids. I said there are variety of solutions, 9 types, out of which solid in liquid is 1. Now, solubility of solid in liquid, if you take, what is solubility? Solubility is maximum amount of solute that is soluble in a saturated solution. I was telling you, in a saturated solution, you can dissolve the maximum. If you add more, it will remain as a solid at the bottom. It does not dissolve at a given temperature. Therefore, solubility is, what is the meaning of solubility? Solubility is the maximum amount of solute present in a given volume solution at a given temperature. Please remember this, at a given temperature. Why? If I change the temperature, solubility also changes. Now, whether the solubility, how the solubility depends. Why more, some solutes are more soluble, some solutes are less soluble. I am giving an example. Let us say, example, why sodium chloride is more soluble, silver chloride is sparingly soluble, less soluble. Why? This is a question for us. Sodium chloride is soluble. You add any amount of sodium chloride, it goes on dissolving. But if you add silver chloride, 1 crystal into 50 ml of water and dissolve, some amount of silver chloride dissolves, but some amount of silver chloride remains undissolved. Why? The reason is, we'll find out the reason. The reason is the lattice. There are 2 things. If hydration energy is greater than lattice energy. Say this. Hydration energy is endothermic, exothermic, negative. Lattice energy is endothermic. This is exo, this is endo. If energy liberated is more than the energy absorbed, then it is energy is liberated, therefore it is soluble. Therefore, hydration energy is more than lattice energy, then it is soluble. If it is insoluble, means lattice energy is more than the hydration energy, then it is insoluble. Therefore, this is the reason why some substances are soluble, some substances are insoluble. Reason is hydration energy and lattice energy. If hydration energy is more, hope you know what is hydration energy. Ions are hydrated. When you put sodium chloride in water, sodium ion gets surrounded by water molecules. That is called hydration of sodium ion. Chloride ions are surrounded by water molecules. That is called hydration of chloride ion. And this hydration energy, which is exothermic, if it is more than the lattice energy, then lattice will break and dissolve. Solute will dissolve. If not, then lattice will not break, solute will not dissolve. That is what is. Next, effect of temperature. You just see what is the effect of temperature here. When a solute is added like this, sodium chloride, potassium nitrate are added to water. Okay, the reaction is endothermic. Heat is absorbed, cooling takes place. Heat is absorbed, cooling takes place, endothermic. Then such reactions, such processes, I don't say reaction, such processes are favored at high temperature. All endothermic reactions are favored at high temperature. Therefore, solubility increases with increase in temperature. For this, solubility increases with increase in temperature. I will write here solubility increases with increase in temperature for such salts. Now, yes, here only best thing. Now we check yes. We will take, if you take salts such as sodium carbonate, lithium carbonate, they are exothermic. Exothermic. Now, if there is exothermic, solubility decreases with increase in temperature. Is it clear? For exothermic salts, solubility decreases with increase in temperature. For endothermic salt, solubility increases with increase in temperature. Yes. Now we go for solubility of gas in a solubility of gas in a liquid. So far we were saying solubility of solid in a liquid. Now we are taking gas in a liquid. Very important law is there called Henry's law. You should know this. What is Henry's law? I will put it here. The volume of gas dissolved in a given volume of liquid is, we can go further, okay, is directly proportional to, this you should know, is directly proportional to the pressure above the gas. I will explain. Let us say carbon dioxide is there and water is there with you. You want more carbon dioxide to dissolve in water and make soda water. What you do is you put carbon dioxide under more pressure, more soda will, carbon dioxide will dissolve in water. Therefore, sometimes if you open soda bottle, lot of gas comes out. Why? When you open soda bottle, the pressure inside is more, pressure outside is 1 atmosphere. When you open, because the pressure is more, only under pressure it was soluble. Now when you release the pressure, gas will come out. Solubility decreases. As you increase the pressure, solubility increases. As you decrease the pressure, solubility decreases. Therefore, mathematically, I can put it this way. PA, it is A is equal to KH into XA. This is Henry's law. Partial pressure of a gas which is dissolved is equal to Henry's constant KH, where KH is called Henry's constant. Henry's constant. And XA is called mole fraction. Mole fraction of the gas. Therefore, what will happen is, if the pressure, partial pressure, if a gas is more here, if the pressure is more, you can notice here, this is the pressure is more, then more gas will dissolve. More will dissolve. More gas will dissolve. Higher the pressure, higher will be the amount dissolved. KH is called Henry's constant. Higher the value of KH, lower is the solubility. Why lower is lower? Lower is the solubility. If KH is more, please notice here, I will show you. If KH is more, XA will be less. I will show you with writing it again. Here we will do it. Here, KH KH is more, solubility is less. Why so? Just check. If I put PA is equal to, this is my Henry's equation, KH into XA, if you write, if pH is more, if pressure is more, XA is more, I was telling, provided KH is a constant. If KH is more, automatically XA become less. The product of these two should be equal to PA. Therefore, if KH is more, XA is less. The XA will speak about the solubility. Now, this is called Henry's law. Therefore, tell me, what is Henry's law? Mole fraction, you can say, mole fraction of the gas which is dissolved in a solution is directly proportional to partial pressure of the gas above the liquid. Mole fraction is directly proportional to partial pressure of the gas above the liquid. That is called Henry's law. Is it not of the type y is equal to, we will use y is equal to mx. You know, how do I plot y is equal to mx? A graph can be plotted. Here you can say partial pressure. Here you can say XA. You should get an equation passing through the origin, correct? You should get the slope should be equal to the slope. You can say slope should be equal to KH. This is what we are saying. Therefore, partial pressure of the gas above the liquid should be equal to, is directly proportional to XA. It should pass through the origin. I have put it a little up, but it should pass through the origin. Okay. Next we move. We'll take, yes. Once we finish Henry's law, what is the application of Henry's law? Application of Henry's law. Point number one. What will happen is carbonated beverage. I will not write all those things. I will only explain. As you put more pressure of carbon dioxide, more carbon dioxide will dissolve. If you put carbon dioxide at low pressure, less carbon dioxide will dissolve. This is what we see. Therefore, when you open the bottle of the carbonated drink or a soda water, what happens? Bubbles are seen going out because pressure decreases as the solubility also decreases, carbon dioxide escapes out. That's the first point. Second point, sea diving. What is the meaning of sea diving? If a person is getting deep into the sea, what happens? Pressure increases. When the pressure increases, if you are using ordinary gas, what is that? Oxygen cylinder, what will happen? More oxygen will dissolve. More oxygen will dissolve in the blood. When the person is coming up, the oxygen will come out of the veins, causing serious pain. And that is a real problem. And to avoid that, what they do is they mix oxygen with helium. Instead of nitrogen, air contains oxygen and nitrogen. Nitrogen atomic mass is, molecular mass is 28. Helium is only 4. And solubility of helium is less. Solubility of nitrogen is more. Therefore, this will be less soluble. If at high pressure also, amount of helium dissolving is very less. Therefore, it will not cause that much pain. Okay, this is another. Third one, if you go to high altitudes, you climb about, let us say, 15,000 feet and above. If you go, their oxygen will be very less in that setup. Therefore, you will have a breathing problem. You will become dizzy. You will have lower concentration because we know that hemoglobin combines with oxygen to form oxyhemoglobin. You don't get enough oxygen, there will be a problem. Therefore, high altitudes, this problem is there. When the pressure is, outside pressure is there, solubility is also less. Yes, this should be known. Next we go for, we move further, we move on to ideal solution. This part is clear. What is an ideal solution? Please notice. I am speaking about two liquids, not two solids. Solution of liquid and a liquid. This I will take. What is the ideal solution? If you have ideal solution of two liquids, it obeys Raoult's law. What is Raoult's law? It obeys Raoult's law. That is the meaning. Both components obey Raoult's law. Both components obey Raoult's law. What is this? How do I put it? If I say one component is A, another component is B, one component has this, PA is equal to XA into P naught A, Another one is PB is equal to XB into P naught B. This is Raoult's law. If the partial pressure of each component, is the product of mole fraction of that component and vapor pressure of the pure component. Partial pressure of each component is mole fraction and vapor pressure of the pure component. If you go to the other side, partial pressure of B is the mole component in this one, mole fraction of B and vapor pressure of the pure component. If this is obeyed, then it is called ideal solution. Therefore, what is ideal solution? Please remember, ideal solution is one in which all the components obey Raoult's law. If there are two components, A and B, both should obey Raoult's law. Then only it is called ideal solution. I will give characteristics of ideal solution. Characteristic. Ideal solution. What is the characteristic of ideal solution? Ideal solution characteristic is when I mix the two components A and B, right here, one, force of attraction between molecules of A and force of attraction between molecules of B should be almost same. I will explain this way. If there is a force of attraction between A and A, B and B, that should be equal to A and B. Now let us take, you have two solutions, benzene and toluene. Force of attraction between molecules of benzene and force of attraction between molecules of toluene should be equal to force of attraction between molecules of benzene and toluene. That should be the condition. That is one condition. Second condition is both components obey Raoult's. Third condition is if I mix the two components, there is no change in enthalpy. No heating, no cooling takes place. Fourth condition is there is no change in volume. What does it mean? If you mix 50 ml of A with 50 ml of B, total volume becomes 100 only, nor 99, nor 100.2. Exactly when you mix the two, their volumes will be equal, their enthalpies will be zero, there is no change in enthalpy, volume also does not change. And fifth I can say, fifth I will write here, fifth, the components, we'll take it down, yes, can be separated by fractional distillation. You can separate the component A and B by fractional distillation. These are called ideal solution. I will give examples. Ideal solution I have explained. Let me give examples. Examples are these. One is benzene. The homologous series member of benzene is toluene, C6H5CH3. Therefore, structurally they should be identical. Then only they are ideal solution. Another example. We will take cyclopentane plus cyclohexane. Even you can take heptane, hexane and heptane. That also normal cyclobacal. Heptane and hexane. Like this you can take. or you can even take ethyl bromide plus ethyl iodide. These are varieties where we can have ideal solution. Next, if you move to the next one, what is non-ideal solution? Liquid in liquid, I am speaking about non-ideal solution. Non-ideal solution is one where both components do not obey Raoult's law. They don't obey Raoult's law. Now you check, what if they don't obey Raoult's law? PA is not equal to XA into P naught A. Similarly, PB not equal to XB into P naught. When I say not equal, it could be either more or less. Two ways are there. Therefore, non-ideal solutions are of two types. One showing positive deviation from Raoult's law, another showing negative deviation from Raoult's law. Therefore, there are two types, non-ideal. There are two types. One showing positive deviation from Raoult's law. Another one, second one, showing negative deviation from Raoult's law. Therefore, there are two. One showing positive deviation from Raoult's law, another showing negative deviation from Raoult's law. Let me take the first one. First, positive deviation from Raoult's law. What should happen? Here, the PA should become greater than XA into P naught. PB should be greater than XB into P naught B. Greater. Why? What is when it will happen? The reasons will be here. One, the condition is the force of attraction between A and B is more than A and B. As a result, what will happen? When I mix A and B, the molecules try to move away. Instead of coming closer, they move away. As a result, what will happen? They repel each other. Therefore, second point is when they repel each other, heat will be absorbed or evolved is a question. When you mix the two, we have to take, let us take this case, delta H mixing. Delta H is positive. They try to absorb heat, therefore cooling takes place. Cooling takes place. There was neither heating or cooling in the ideal case. Here it is cooling takes place. Third one, volume delta V is positive, means volume also increases. For example, 50 ml of alcohol and 50 ml of water, if I take, together it will become more than 100, 100.01, 100.02, something like that. There is an increase in volume that is obtained. And the fourth point is the components cannot be separated. By distillation, fractional distillation, I am not able to separate A and B because Here I will write because it forms azeotropic mixture. Tropic mixture. What is the meaning of azeotropic mixture? A mixture which distills without change in composition is called azeotropic mixture. What is the meaning of that? I will explain with an example. If I have 95.5% alcohol and 4.5% water, any number of time you distill, the composition will not change. It will remain 95.5 and 4.5. That is called azeotropic mixture. Therefore, here you get an azeotropic mixture. Which are the examples we can take here? We will take here. Examples for one showing positive deviation from Raoult's law. I am taking examples. One is ethanol and water. This is one example. You can also take methanol and water. You can take ethanol and acetone. Acetone is CH3, CH3. You can even take benzene and acetone. These are examples which show positive deviation from Raoult's law. One showing positive. Therefore, when you mix such solution, cooling observed. Second, volume increases and both the components show positive deviation from Raoult's law. The reason is attraction between A and B will be less. Attraction between A and A is more, B and B is more. Attraction between A and B is less. We go to the third variety. Solutions showing negative deviation from Raoult's law. It show negative deviation from Raoult's law means what? When does it happen? If PA, that is the first one, is less than XA into P naught A. Similarly, PB is less than XB into P naught P, if you take. If these two are taken, PA is less than this and PB is less than this, then it is called negative. When it will happen, what are the characteristics? We will write one by one. Point number one. One, attraction between A and B and B is less than attraction between A and B. Means the two components attraction is more and attraction between individual component is less. As a result, what would happen is second point is here. Second point we take. Second point is when you mix, delta H becomes negative. What does it mean? It becomes exothermic. Heating takes place. Heating takes place. When I mix the two liquids, heating is observed. Then it is second one. Third one, delta V is less than 0. Volume decreases. If I take 50 ml of A and 50 ml of B, total volume will never become 100, it will become less than 100. That is what the meaning is. And the fourth one is the two components cannot be separated by fractional distillation. Why? As it forms azeotropic mixture. As it forms azeotropic mixture. Here also you get azeotropic mixture. Not only in that case, here also you get azeotropic mixture. The components cannot be separated by distillation. You have to go for some other method of getting this. Therefore, what we notice here is, can we answer a question? First question I have given it. What is the difference between an ideal solution and a non-ideal solution? I will give that. Ideal solution, both the components obey Raoult's law. Non-ideal, they may not, both the components do not obey Raoult's law. First point. Second, the force of attraction between A and B is equal to force of attraction between A and B. That is ideal. Here, non-ideal, force of attraction between A and B is not equal to force of attraction between A and B. Either it is more or less. Third one, when you mix, delta H is 0 for ideal. No heating, no cooling takes place. But when you mix, either heating or cooling takes place. Delta H is positive or negative. Fourth one, the two components can be separated by fractional distillation, but here the two components cannot be separated by fractional distillation because it forms an azeotropic mixture. This is about ideal solution. This is the topic. Now we will be going for, you have to just check, yes. We will, in the remaining time, just I will introduce what is colligative property. Yes. These are very special properties. Colligative properties are special properties. They do not depend upon quantity of matter present, nature of the solute. Sorry, I can put. They do not depend upon nature of solute, but depends only on number of particles present in solution. I will explain this, how it is, and then we'll do that. For example, if you take 1 mole of glucose solution, 1 molar glucose solution, you have to dissolve 180 grams in 1 liter. That is 1 molar glucose solution. 1 molar urea solution, you have to dissolve 60 grams of urea in 1 liter. 1 molar if you have. These properties will have identical values because both will contain Avogadro number of particles. 1 mole contains Avogadro number of particles. There it contains Avogadro number of glucose molecules. Here it contains Avogadro number of urea molecules. Therefore, these properties depend upon number of particles present in the solution. They do not depend upon whether it is glucose or urea or sucrose. It does not depend. Such properties are called colligative properties. I am taking 4 of them under this. 1, relative lowering of vapor pressure. This is one property. Second, osmotic pressure. The second property. Third, elevation in boiling point. Third property. Fourth, depression in freezing. These are 4 colligative properties. Therefore, what are colligative properties? They do not depend upon the nature the solution, but depends only on the number of particles present in the solution. They are mathematically written like this. We can write here. Osmotic pressure is given as pi. Relative lowering of vapor pressure is given by P naught minus P divided by P naught. This is how you write. Elevation in boiling point is written this way, delta TB, and depression in freezing point is given as delta TF. Therefore, dear students, we have colligative properties. Very important topic this is. How many colligative properties are there? What are colligative properties? I repeat again. These are the properties which do not depend upon the nature of the solute, size of the solute, but depends only on number of particles present in the solution. That are called colligative property. And there are 4 colligative properties you can see: relative lowering of vapor pressure, osmotic pressure, elevation in boiling point, and depression in freezing point are the cases. If you continue with that, at least I will take one of them.
Sir, if you take another 5 to 10 minutes, sir,
Yes, sir?
you have to take another 5 to 10 minutes.
Yeah. Otherwise, I can wind up also, but actually it requires time.
Okay, okay, sir.
Okay. I will take up Van 't Boy's law. What is Van 't Boy's law? Van 't Boy's law is, you should know what is Boy's law. Apply that for solution, then becomes Van 't Boy's. Boy's law is for gases. If you apply it to solution, it is called Van 't Boy's law. Now let me explain what is Boy's law. Boy's law is relationship between pressure and volume at constant temperature. Volume of a given mass of gas is inversely proportional to pressure. I will give you. Volume of a given mass of gas is inversely proportional to pressure at constant temperature. That is called Boyle's law. Now this is applied to dilute solution, then it becomes Van 't solution. What it says is osmotic pressure. When you apply dilute solution, its osmotic pressure is directly proportional to molar concentration, because concentration is 1 by V. If 1 mole is present in V liters, concentration is given as 1 by V. Therefore, osmotic pressure is directly proportional to concentration of the solution. This is called Van 't Boy's law. See, instead of pi, I have P. Instead of C, I have V. Is it not? P is inversely proportional 1 by V. P is inversely proportional 1 by V. Pi is inversely proportional 1 by V. That is C. This is called Van 't Boy's law. Next comes Van 't Charles law. What Charles law says is giving a relationship between V and T at constant P. This is called for a gas. Now we will apply here. Osmotic pressure is directly proportional to absolute temperature. Osmotic pressure is directly proportional to absolute temperature. This is Charles law. Now, what is Van 't Avogadro law? Van 't if you take, here it says osmotic pressure of a dilute solution is directly proportional to the number of moles, where N is the number of moles present in the solution. Therefore, if you club first Van 't Boy's law, second Van 't Charles law, third one is Van 't Avogadro law, all if you club, it will become your combined ideal equation. What is that combined equation? Pi is equal to some value R is a constant, C, P, This we can get pi RCT with n. Sorry, n. This is what we can say. Pi RCT n. Is it not very similar to pi is equal to R T n divided by C is 1 by V. If you write this, pi V is equal to nRT. Check. This is for ideal solution equation. Pi is equal to nRT. Please remember, n is equal to W by M. What is W? Number of moles of the solute, mass of the solute divided by molar mass. Mass by molar mass is number n. Therefore, we can write even this way. Pi is equal to W R T by pi V. Pi V, no? MV, no? MV. Therefore, this is the formula you can use. Pi is equal to W by M, which is N. nRT by V. Check. nRT by V. I have this nRT by V, which is above here. Okay. nRT by V, N is W by M, RT by V. Therefore, for all calculations, we can use this formula. Pi is equal to W RT by MV. Remember this formula for calculation of problems on osmotic pressure. Osmotic pressure. This is an important thing to be known to you. And let me wind up because we are exceeding the time. Therefore, whatever that is discussed in the class of solutions, today you go through that, revise and prepare yourself for the topic on solution. Thank you very much for attending today's class. Hope you have understood what was told or taught in the class. Thank you.
Sir.
I finished, sir.
Sir, the completed?
Yeah.
Dear students, any questions about the solutions?
Topic.
Sir, 1 minute, sir. Check our chat box. Any questions from the students and audience?
Chat box. I will check.
So in the chat box, sir, there is no question, sir.
No question is there.
So ಏನಾದ್ರು ಮೇಲ್ ಐಡಿ ಮುಖಾಂತರ ನನಗೆ ಏನಾದ್ರು ಕಳಿಸ್ಕೊಟ್ರೆ ತಮಗೆ ಮೇಲ್ ಐಡಿ ಮುಖಾಂತರ ಕಳಿಸಿ ನಾನು ಐ ಗೆಟ್
Yes, sir. Sure, sir. ಬಂದಾಗ ಮಾಡುವ sir.
So anyway, I thank you, sir. Thank you very much.
Okay, thank you. Thank you for giving me an opportunity. Thank you very much.
So it's an immense pleasure to thank you, Dr. Richard Gonsalvias, sir, for this wonderful speech on solutions. This talk has given many information to the students. I greatly thank you, sir, from KST and personally, sir.
Thank you very much.
And I also thank our KSTA Chief Executive Officer, Dr. Ramesh, sir, for this encouragement to organize this talent search program. I am gratefully thank you, sir. And I also thank our Chairman Ayappan, sir, and colleagues, technicians, and staff members for their participation to conduct this program. So once again, to thank all you. Okay, thank you, sir.
Thank you very much. Thank you very much, sir.
Thank you, sir. So ವಿದ್ಯಾರ್ಥಿಗಳಲ್ಲಿ ಒಂದು ಸೂಚನೆ, ಸರ್ ಅವರು ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಡಾಕ್ಟರ್ ರಿಚರ್ಡ್ ಗೋನ್ಸಾಲ್ವಿಸ್ ಅವರು ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ 2 ಕ್ವಶನ್ಸ್ ಗಳನ್ನ ನಮ್ಮ ಚಾಟ್ ಬಾಕ್ಸ್ ಮತ್ತೆ ಗ್ರೂಪ್ ಟ್ಯಾಲೆಂಟ್ ಸರ್ಚ್ ಗ್ರೂಪ್ ನಲ್ಲಿ ಹಾಕಿದ್ದು. ಸೊ ಇವತ್ತಿನ ತರಗತಿಯಲ್ಲಿ ಹಾಜರಾಗಿದ್ದ ಎಲ್ಲಾ ವಿದ್ಯಾರ್ಥಿಗಳು ಉತ್ತರಗಳನ್ನು ಬರೆದು ನಮ್ಮ ವೆಬಿನಾರ್ ಗ್ರೂಪ್ ಇಮೇಲ್ ಐಡಿಗೆ ನಾಳೆ ಕಳುಹಿಸಿಕೊಡತಕ್ಕದ್ದು. ಹಾಗೂ ನಾಳಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಡಾಕ್ಟರ್ ಹರಪ್ರಸಾದ್ ನಂಜುಂಡಪ್ಪ ಅವರು ರೀಕಾಂಬಿನೆಂಟ್ ಆಫ್ DNA ಟೆಕ್ನಾಲಜಿ ವಿಷಯದ ಮೇಲೆ ಉಪನ್ಯಾಸ ಕೊಡಲಿದ್ದಾರೆ. ಒತ್ತು ಸೇರಿದ ರೀತಿಯಲ್ಲೇ ನಾಳೆನೂ ಕೂಡ ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿಗಳು ಸೇರಿ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಯಶಸ್ವಿಗೊಳಿಸಿಕೊಡಬೇಕೆಂದು ಮತ್ತೊಮ್ಮೆ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಇಲಾಖೆ ಅಕಾಡೆಮಿಯಿಂದ ಸೂಚಿಸುತ್ತಿದ್ದೇವೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಒನ್ ಅಂಡ್ ಆಲ್. ಥ್ಯಾಂಕ್ ಯು ಸರ್.